Many students think that numericals are very tough. Now they are asking us to calculate mechanical advantage, velocity ratio, efficiency. Children, this 10th numerical is not a regular numerical. It is not a direct numerical. Hello children, in today's class we will be solving the numericals based on machines, especially exercise 3B. Dear children, in a previous classes we solved the numericals based on exercise 3A, and also we uploaded machines chapter in detail, that is topic wise we uploaded, even one short video also uploaded actually. So all the links will be given in the description. Just go to those videos before going to watch this video so that you will get a command. Okay, fine. So especially children, in today's numericals purely based on the pulleys children. So here we have a single fixed pulley, single movable pulley, and next also we have a block and tackle system actually. So here one important point we need to recall here. First of all, how to calculate mechanical advantage. So mechanical advantage is equal to load by effort. Okay, we are not going to use effort arm by load arm here because we are not going to deal with the levers. That is only for levers. So here strictly mechanical advantage is equal to load by effort, and efficiency is equal to mechanical advantage by what we can say velocity ratio. And one more important thing we need to recall here. For single fixed pulley, mechanical advantage is 1. For single movable pulley, mechanical advantage 2. At the same time, in the case of single fixed pulley, effort applied is always equal to load. Okay, but whereas in the case of single movable pulley children, single movable pulley, effort is always equal to the half of the load given. Half of the load given. So these 2 points which we should remember. Next come to the block and tackle system here. So block and tackle system means velocity ratio depends on that number of pulleys. Okay, and here one more very important point here. So for a given system, for a given design of a machine, velocity ratio always remains constant unless and until you change the design. Velocity ratio won't change. It only mechanical advantage changes, hence efficiency changes. Is it clear? Fine. Now just let us start a first numerical. Let us see the first numerical children. So as per the numerical, it is given that so woman draws a water with the help of single fixed pulley. For that she is applying an effort of 70 newtons such as that 6 kg of water, means including, you see 6 kg is the mass of the bucket come water. So she is able to pull. Okay, further how much effort she is putting? She is putting 70 newtons. Now it is asked us to calculate the mechanical advantage. Children, let us recall the mechanical advantage formula here. So we know that mechanical advantage is equal to load by effort. But if you can see the numerical, effort is given but load is not given. That is what actually here logic here. But here mass is given. So you may get one doubt, sir, if mass is given, how can we calculate the load? Hey, load is what? It is nothing but what? Force of gravity. Okay, so here L is equal to, okay na, force of gravity is what? How to calculate? M into G, that is nothing but the weight. So mg. So M is 6, G is 10. So this is 60 Newton. Now you apply this formula, we will get mechanical advantage is equal to load by effort. 0 cancel. If you can calculate, you will get 0.857. Children, here you may get one doubt. Sir, for a single fixed pulley, mechanical advantage is equal to 1. But here we got less than 1. What does it mean, children? It means that it is not an ideal pulley, rather it is an actual pulley. Children, for actual pulleys, for practical machines, the efficiency can't be 100%. Why? Because of friction and many other factors. Okay, fine. Now come to the second question, children. So this second question quite interesting, many students, first of all, they will fail to understand the question. Solution is easy only, but the thing is that they will fail to understand the question. That is a problem. Okay, yes. So look at here, it is given that single fixed pulley only. So this single fixed pulley is driven with a 100 kg of mass, which means what? This 100 kg of mass is falling at the rate of 8 meters in 4 seconds. As this 100 kg block is falling down, this 75 kgf is lifted. So which means what here? Who is applying the effort here? Yes, 100 kg and the force of gravity acting on it. Try to understand. So, as this 100 kg body is falling down such that it is covering 8 meters in 4 seconds, this 75 kgf block is lifted. Okay, fine. Now they are asking us to calculate power input, efficiency and load displacement. Children, if you want to calculate the power, of course, power means generally what we think it's a work by time. Yes or no? But here work is not involved. Of course, work is done. Okay, no, but no need to go for that formula. We have done formula, right? One more formula. Power is equal to force into velocity. Force into velocity. Again, here a doubt comes to our mind. Sir, force means somehow we can. Velocity, how can we calculate velocity? Yes, here we know. So, children, velocity is equal to here effort displacement by time. That is 8 by 4. So, it is a 2 meter per second. So, velocity is calculated. But force means how to calculate. Children, very, very important. So, it is given that they are asking us to take, okay, na, that force of gravity on 1 kg mass is 10 newtons. Force of gravity acting on 1 kg mass is 10 newtons. Then how much force will be acting on 100 kg? And 1 kg 10 newtons means obviously 100 kg 1000 newtons and 100 kg. So 100 into 10, it is a 1000 newtons force acting. 1000 newtons force of gravity is acting. It is pulling. Okay. Now look at here, it is 1000 into 2. So this will be 2000 watt or 2 kilowatt. This is how we can calculate in a simple manner, children. Let us not make it complicate. Let us not make it complicate. Okay, fine. And efficiency they are asking, children. So efficiency means how to calculate here. Efficiency is equal to, we know that mechanical advantage by velocity ratio. Again here, look at here, mechanical advantage is not given, velocity ratio also not given. Now we need to calculate, children. So let us recall here. First of all, children, here velocity ratio is equal to what here? Effort displacement by load displacement, right? Effort displacement by load for a single fixed pulley in an ideal case only. So effort displacement is always equal to load displacement. Means here, if effort is moved downward direction by 8 meters, obviously load also is lifted vertical upward by 8 meters. So it is a 8 by 8. So it is velocity ratio is 1. That's okay. So velocity ratio is 1. Then what about mechanical advantage? Yes. So mechanical advantage is equal to, we know that it is a load by effort. Children, effort is nothing but already calculated. So 100 kg on 100 kgf, what is the force acting on the gravity? 1000 newtons. That is 1000. Effort is 1000 only. But load is how much here? Yes, 75 kgf. But we have to convert into Newton. 1 kgf is equal to 10 newtons. So 75 kgf is equal to 750 newtons. So this is 750 newtons. Hence this is going to be a 0.75. Right? Now put here, this is 0.75 by 1. So which means what here? It is 75%. Anyhow, third bit they are asking us to calculate load displacement. So load displacement is how much? 8 meters only. Why? Because the effort displacement is equal to the load displacement. As the effort is moving downward by 8 meters, obviously load also lifted by 8 meters. Is it clear? Yes. Now, come to the third question. Actually, it is a conceptual question. It is not a numerical. It is. Okay. So, what happened, by seeing the question, first of all, students will start using some formulas and all these things. It's not that. First, read the question carefully. Read the question carefully. Then it will become very easy to us to solve it. Okay. Fine. So, as per the question, it is given that. So, we are using single fixed pulley, single movable pulley. Okay. And they are asking us to find the ratios of efforts applied with a single fixed pulley, single movable pulley in order to lift the load of 50 kgf. 50 kgf. Children, in the case of single fixed pulley, we know that effort is equal to load. Effort is equal to load. So, which means what here? What is the effort required by a fixed pulley, children? Obviously, 50 kgf. Okay. And in the case of single movable pulley, it's very important thing is that always the effort is always equal to the half of the load. Okay. So, that is what half of the load means what here? 50 by 2. It is a 25 kgf. 25 kgf. Now, ratio means what, children? Very simple. It is EF is to EM is equal to just 50 is to 25. 50 is to 25. It is nothing but 2 is to 1. 2 is to 1. Okay, na? So the effort applied in the case of single movable pulley is less. That's what single movable pulley is used as a force multiplier. Clear? Fine. Now, fourth one, children, here. So here it's the question is based on the block and tackle system. Block and tackle system it is. So here it is given that a number of pulleys in that block and tackle is 4 and a load of 75 kg. In order to lift that, effort 25 kg is placed. Now they are asking us to calculate mechanical advantage, velocity ratio, efficiency. Here the thing is that to calculate the velocity ratio, many people will they'll be doing like anything. But velocity ratio, how to calculate the velocity ratio, children? Just wait and see, we will tell. Okay, so first mechanical advantage. Yes, mechanical advantage is very simple. So mechanical advantage is equal to, we know that it is a load by effort. So this is 75 by 25. So obviously it is a 3. Okay, yes. Now second one, if you can see here, velocity ratio, right? So velocity ratio, children. Velocity ratio is blindly put right n. What is n here? Yes, velocity ratio is equal to the number of pulleys in a block and tackle system, provided effort is applied downward direction. This is a very important point. It is not always velocity ratio is equal to the number of pulleys, children. Only when the effort is applied in a convenient direction, that is the downward direction, only in that case only we should take velocity ratio as number of pulleys. So how much it is? 3. Okay, fine. Now they are asking us to calculate the efficiency. Efficiency is equal to mechanical advantage by velocity ratio, that is 3 by 3. It is 1 or 100%. That's it. This is how we can solve the numericals. Okay. What assumption are we making? So children, here look at the numerical 5. It is given that it's a block and tackle system in which they only give that number of pulleys are 5 and effort 1000 Newton is applied downward direction in order to lift the load of 4500 Newtons. Now they are asking us to calculate the mechanical advantage, velocity ratio, efficiency. Okay, children. So here first one, mechanical advantage. Yes, we know this, that is load by effort. So which is nothing but 4500 by it is 1000. So children, this is going to be a 4.5. So mechanical advantage is equal to 4.5. Okay. Now children, how to calculate the velocity ratio of the block and tackle system? So here velocity ratio is nothing but what, children? Here number of pulleys. So number of pulleys are how many? 5. Children, look at here. Is it ideal block, ideal system or actual system? Actual system only. You may get one down. Sir, how can we say that given block and tackle system is ideal or actual? So here if you can see, if the mechanical advantage is equal to velocity ratio, then it is a ideal system. So in all other cases, that is in all practical cases, mechanical advantage is less than velocity ratio. Okay, fine. Now, how to calculate the velocity ratio? Sorry, efficiency. Efficiency is equal to mechanical advantage by velocity ratio. If you can put here, this will be 4.5 by what is the 5? So this is going to be a 45 by 50 into 100, 51s, 52s. So this is going to be a 90%. So for an ideal machine it is a 100%. Whereas for an actual machine it is a less than 100%. Why? Because as I told you that like a friction might be, friction is involved, not might be, friction is involved actually. That one is enough to reduce efficiency, right? Okay. In the sixth question, already diagram is given. They are asking us to complete the diagram and they are asking us to show the direction of tension, direction of load, direction of effort. Okay. So you can see that answer diagram on the board. Okay. So that is what actually you have to practice, and it should be very it should be practiced, and it's very important. Okay, fine. And they also given that if a load is displaced by 1 meter distance, so they're asking us to find the displacement of effort. Children, we know that velocity ratio is equal to effort displacement by load displacement. Effort displacement, load displacement. So from this, effort displacement is equal to velocity ratio into load displacement. Here you may get one doubt. But sir, how to know velocity ratio? Velocity ratio is not given. Children, Velocity ratio is nothing but what, students? Number of pulleys. How many pulleys are given? 5 pulleys are given. So 5, that's what here it is written 5, number of pulleys, children. So this is 5 into 1. So this is going to be a 5 meters. So 5 meters displacement. So when a load is displaced by 1 meter, effort is displaced by 5 meters. Now they are asking how many number of strands are supporting. So it's very important. How many strands of the what we can say block and tackle system is supporting the load, children. If you can just notice a diagram here, total 5 will be there here. 5 strands, children. 5 strands are supporting. See, one strand is supporting the effort. Remaining 5, total if you can see 6 strands are there. Out of the 6 strands, 5 strands are supporting the load. So the answer will be 5. Now they are even asking us to calculate the mechanical advantage, children. So here, fine. So mechanical advantage, children. So as I told you that here effort is balanced by one strand, in that one tension is there, whereas load is supported by 5 tensions. So mechanical advantage is equal to load by effort. So this is 5T by T. T gets cancelled. So mechanical advantage is equal to 5, children. So if you can see here, velocity ratio is 5, mechanical advantage is 5, which means what? It is a just ideal system. It is just a ideal system. Okay, fine. Now come to the 7th numerical, children. So here it is given directly that velocity ratio is equal to 3, and they are asking us to draw the diagram. Yes, diagram is shown on the screen, so you can just copy the diagram. Okay, fine. Now it is also mentioned that load is 150 newtons and effort is 60 newtons. They are asking us to calculate the mechanical advantage. Yes, it's a direct formula. MA is equal to load by effort, which is equal to 150 by 62.5. We get it. Okay, fine. Now come to the numerical 8, children. Here the incompleted diagram is given. They are asking us to complete it. Okay, fine. So as usual, the answer diagram is shown on the screen. Just you can copy the diagram. Yes. So other than this, they are asking us to calculate the velocity ratio. Children, how many number of pulleys are there in the diagram? If just you can see, 4 number of pulleys are there. 4 pulleys are there, right? So velocity ratio is 4. Now they are asking us to find the relation between load and effort, children. Here only one thing in a diagram, just kindly I think the right side. Okay, so you can see the diagram right side. I think so. Right or left depends on the, it's editing. Okay, fine. So now what I mean to say that in that diagram, if you can notice here, first of all, effort is balanced by one strand in which one tension will be there. So effort is equal to T. If you can notice, load is balanced or supported by 4 strands. In each strand one tension. T. Total 4 T's will be there. 4 T's. That's it. Now if you can see, as L is equal to 4T, T is equal to E. So can I write L is equal to 4E? Yes, you can write. As L is equal to 4E, or effort is equal to L by 4. Now in the last bit, they are asking us to solve all these things, what assumption are you making? So it's very important here. Yes, we are assuming that effort is applied in a downward direction or convenient direction. You may get one doubt, sir, how can you say that we assume this one? Children, again I'm telling you, only when the effort is acting downward direction in a convenient direction, then only velocity ratio is equal to the number of pulleys. As I am taking velocity ratio is a number of pulleys, yes, it is also understood that I assumed that effort is acting downward direction. Is that clear? Just copy this. Pulleys, 3 strings are given. They are asking us to make a diagram. Okay. So come to the numerical 9, children. So as per the question, it is given that in a given block and tackle system, the number of pulleys are 4. They are asking how many strands are supporting the load. Children, already we all know that based on the diagram, if you can see here, so effort is balanced by 1 strand, but in this case here, load is balanced by 4 strands. It is 4 strands, and they are also asking us to complete the diagram and show the directions of tension. Yes, we have shown on the board, you can see. Now they are asking us to calculate the mechanical advantage, children. It's very important. So as we know that effort is balanced by 1 strand, that is 1 tension, and the load is balanced by 4 strands, that is the 4 tensions. So this will be load by effort, right? So that is 4t by t. So t gets cancelled and here is a 4. Okay, fine. Now if a load is displaced by 1 meter, they are asking us to find the displacement of the effort. Children, we know that here velocity ratio is equal to effort displacement by load displacement. From this here, effort displacement is equal to velocity ratio into load displacement. But you may get one out, sir, velocity ratio is not given. Yes, it is not given, but number of pulleys are given. So velocity ratio is equal to the number of pulleys where effort is applied downward direction. Whether it is given or not, we will assume it. Okay, fine. So it is nothing but 4 number of pulleys. So it is a 4 into 1. So this is a 4 meter is the answer. Okay, fine. Now in order to lift the load of 100 newtons, what should be the effort applied? Children, we know that here mechanical advantage is equal to load by effort. From this, if you can see, effort is equal to load by mechanical advantage. Load is how much? 100 newtons, and your mechanical advantage already we calculated it as a 4. So 100 by 4 is how much? It is a 25 newton. So in order to lift the load of 100 newtons, how much effort we should apply? Children, it's a 25 newton. Fine. This, children, very important. This is a very important where many students will get confused here. Okay, it is given that if the weight of the movable block is doubled, then how velocity ratio gets affected? They are asking us to calculate the velocity ratio. Children, we should remember only one thing. Because we are changing the weight of the movable block, do you think that the design will be changed? No, design is not changed. Children, as the design is not changed, velocity ratio remains constant because velocity ratio depends on the design of a given machine. So because we are changing the weight, yes, mechanical advantage will get affected, efficiency will get affected, but not velocity ratio. So the velocity ratio is as usual. Here is 4 means 4 only, 8 means 8 only, 10 means 10 only. That's it. Okay, fine. Dear children, this 10th numerical is not a regular numerical. It is not a direct numerical. So if you can just approach direct method and whatever we knew previously, definitely you get a wrong answer. Here this numerical is purely based on the practical case. Very clearly it is said that yes, the efficiency is just 60% only, which means what here? Yes, lower block has some weight, means weight of the lower block is involved. So whenever weight of the lower block is involved, then how to calculate the load? So if you want to calculate the load, children, first we must calculate the weight of the lower block. But how to calculate the weight of the lower block? Look at, children. So here we have efficiency is equal to, we have 1 minus W by N into E. N into E, look at here. So efficiency 60%, which means what? It is nothing but 0.6. So here is 0.6 is equal to 1 minus W by N. N is what? Number of pulleys. Number of pulleys is nothing but what actually? Velocity ratio only, right? So it is a 3 into, so let it be effort in kgf only, it is a 200. So this is going to be a 0.6 is equal to 1 minus W by 600, and this is going to be a W by 600 is equal to 1 minus 0.6 will be 0.4. So W is equal to 600 into 0.4, you will get a 240 kgf. So this is a weight of the lower block. Because of this weight only, what happened? Efficiency got reduced to 60%. But now they are asking us to calculate the load, right? How to calculate the load? Yes, so let us write here. Children, load is equal to NE minus W. So N is what here? Number of pulleys 3, E is the effort 200 minus weight of the lower block we got 240. So this is going to be a 600 minus 240. So if you can see, this is going to be a 360 kgf. So this much amount of what we can say load is lifted in this particular case. Okay, fine. Now as usual they are asking us to calculate what, children, here. So load displacement, let me check here. Yes, some more part they are asking us to calculate even load displacement. Sorry, not load displacement, effort displacement they are asking us to calculate. So here load, I think effort is displaced by, is it given? Let me check the numerical. So yeah, so effort displacement is given 60 centimeters. Okay, so we know that here velocity ratio is equal to effort displacement by load displacement. So load displacement is effort displacement by velocity ratio. Effort displacement is given in the question, that is a 60. The velocity ratio also given in the question, that is a 3. So this is nothing but 20 centimeters. 20 centimeters. Clear? Children, this is not a regular numerical. Children, this is not a casual, it is not a simple numerical. Don't approach the direct method it is. Okay, where is efficiency 60%, which means what? Weight of the lower block is involved. If you can calculate the weight of the lower block, then only we can calculate the what we can say load. And children, here is we have a last numerical. This numerical is based on the combination of one single fixed pulley and many movable pulleys. According to the question, it is given that 4 pulleys and 3 strings are provided. First, they are asking us to connect, so that to show in a diagram. Yes, diagram is shown on the board, on the screen. You can just copy that. And here, they are asking us to, what we can say, if the mechanical advantage of the system 8, mechanical of the given system is 8, they are asking us to calculate how many number of mobile pulleys are involved in this. How many number of mobile pulleys? Is it true? Let me check once. Mobile pulleys, what they are asking? Draw the diagram. Okay. What assumption have you made to obtain the required mechanical advantage? Yeah. So to have a mechanical advantage this much, actually, what are we going to do? Look at here. This is a formula. For this case, mechanical advantage is equal to 2 power 8 children. So n is what here? Movable pulleys only. Strictly movable pulleys only. So which means what here? 8 is equal to 2 power n. So 8 can be write like this. 2 power 3 is equal to 2 power n. Now you can just compare here, so that you will get a n is equal to 3. So 3 is what here? Number of movable pulleys, which means what? In a given system, 3 movable pulleys, 1 fixed pulley is involved. That's it, children. So numericals are as simple as that. See, again I'm telling you, many students think that we can't do the numerical. Many students think that numericals are very tough. So it is not true, children. It is not true. So what we have to do? Only one thing. See, first, anyhow, you should go through the concept. You should be thorough with the concept. So whenever you are solving the numerical, children, just go through the numerical. First, read the numerical. Try to visualize the numerical. Try to make a related rough diagram. Try to note down the data given. Then think what is given, what to be calculated. Definitely that particular formula or a concept will come to your mind. Then apply the concept. Then you will get that particular solution. Okay, children. Thank you so much. All the very best.